Hello, welcome to Thriving Academy. In today's video, we'll be looking at an example of the application of finite difference approximation using the explicit method. So these examples, if you look at the equation below, the equation asks us to use the explicit method to calculate for the pressure distribution during the first year of production. So these are the given parameters in the equation. The equation gave us this particular grid system and also gave us this equation. Remember our last class that in our first explicit derivation, we make use of a simple pressure equation. That particular equation does not involve the flow rate. But in the equation that they gave us for this grid system or for this reservoir, the equation involves flow rate and also involves what? All these parameters. So if you have this kind of equation that asks you to use the explicit method, the first step is to derive the general pressure equation that you are going to use to predict each of the pressure in each of the grid system from 1 to 5. So let's analyze the equation. So first of all, we are going to analyze the equation that they gave us and derive the general pressure equation. Let's analyze the given equation. So we have this. So first of all, let's analyze this. We are going to use this to open this bracket. Remember that this d over dx is multiplying this bracket and also delta x is multiplying this bracket. So first of all, let's open this bracket. If we use d over dx to multiply this equation, you can simply say that this one here is the same thing as this is the same thing as d over dx multiplied by dp all over dx. If these two multiply, d times d here will give us the square, then the x times the s will give us the x square. If that is the case, we are going to have this left hand side will also be equal to the square of p, divided by the x square. So if we use this to multiply this and write the other parameters, it's also the same thing. So this will give us the square p over the x square multiplied by bc ax kx. Remember that the bc is here. Since it's here, it means so it's multiplying this, but also we can simply put it at the numerator. And also, since delta s is here, it's also multiplying this. So we can simply also put delta x at the numerator. If we do that, if we put this one into at the numerator and also put this at the numerator, we are going to have bc ax kx delta x all divided by mu L BL all divided by mu L then BL. Then we have plus QSC. So this becomes plus QSC is equal to. Now also, let's write this other side. There's no bracket here, so there's no need to expand here. So this becomes equal to VB phi CL divided by AC BL dot multiplied by dP divided by dt. So we have this. Since we already have this, the next step now is to divide through by the coefficient of dP over dt. Divide through by the coefficient of dP all over dt. If we just like multiplying by 1 all over the coefficient of dP over dt, you know that the coefficient of dP over dt is this. So if we divide through by this, we are going to have the square p divided by the x square times bc ax kx delta x divided by mu L BL. Now this one is just for this one. So we are dividing through by the coefficient of this. So if we divide through by this, if we come here now, this other side will become what? The inverse. So if it becomes the inverse, this will become what? Multiply by what? The inverse is this side divided by this side. So this becomes AC BC dot divided by VB phi CL. So we are going to have this. This one is just for the first parameter. The second one, I will remember that we also have plus QSC here. So this division now also affects what? The QSC. If it affects the QSC, this becomes plus what? This will become plus AC BC dot all divided by what? VB phi CL. All divided by VBI phi CL, then multiply by what? QSC. So this becomes times QSC is equal to what? dP divided by dt. So we have this. We have this. The next step now is, since we have everything here is equal to dP all over dt, all right, we can simply substitute the value. Remember that from our explicit derivation, we said that dP over dt is equal to pi n plus 1 minus pi n divided by delta t. And also, the square p over the s square is equal to pi plus 1n minus 2pi n plus pi minus 1n divided by delta s square. So in place of the partial d square p over partial dx square, which is this, substitute this equation. Then in place of partial dp over partial dt, substitute what? This equation. If we do that, we are going to have, remember this is partial d square p over dx square. So I'm going to substitute this, which is pi plus 1n minus 2pin plus pi minus 1n divided by delta x square. So we have this. This one here now is just for the square p over the x square. Then write out the other constants, which are multiply by BC AX KX delta x all divided by mu L BL. Then multiply by AC BC divided by VB phi and CL. Now we have this for the part here. Okay, this is BL dot. This is BL dot. So we have this. Then plus, which is this plus here. We have AC BL dot divided by VB phi CL. Then multiply by what? Multiply by the QSC equal to dP dt. Now, what is our partial dP over the partial? They say partial dP dt is equal to this. So this will be equal to pi n plus 1 minus pin divided by delta t. So we have this. So if you look at this now, remember that this one here is multiplying this one. If that is the case, delta x can cancel out one of delta x square here. So this will cancel one from this. So if this cancels one, we are going to have pi plus 1 minus 2pi n plus pi minus 1n. Now, this is divided. Remember that delta x cancel 1 from delta x square here. So we are left with just what? 1 delta x at the denominator. Instead of writing it at this point at the denominator, since it is multiplying this one, you can simply bring the delta x from here to this particular what denominator. So if we do that, we are going to have this one here multiplied by bc ax kx divided by mu l bl delta x. So this delta x that's remaining here now will be here, then multiply by AC BL dot divided by VB phi CL. This is equal to PI n plus 1 minus PIN divided by delta T. Remember that in the explicit method, our aim is to make PI n plus 1 square root of formula because this is the only unknown here. PIN is known, Pi plus 1 is known, Pin is known, Pi minus 1 raised to pi n is known. So all the pressure here are known. This is what? The only unknown pressure. Since it's the only unknown pressure, all we have to do is to make this unknown pressure now the subject of what? Formula. For us to make this subject of formula now, we have to what? Since it's dividing delta t, what do? We have to multiply through by what? Delta t, such that delta t will be able to cancel out delta t from here. If we do that, if we multiply through by delta t, we will have so after this first part, which is this, we are supposed to add plus ACBL VB phi CL. So this is what it is. Then dot QSC will give us this. So let's make PIN plus 1 square formula. We said that we have to multiply through by what? Delta t, such that if delta t multiplied by this, so we cancel out what? Delta t. Also, we are going to write the equation now from the right hand side to the left hand side. So let's take this side first, and before what? We take this other side. And at the same time, we are still going to multiply through by what? Delta t. So if we do that, we are going to have Pi plus PIN plus 1 minus PIN will be equal to, I said that we are going to write the equation from this side and also multiply through by delta t. So you multiply this by delta t will cancel out what? Delta t from here. We'll be left with PIN plus 1 minus PIN, which is equal to what? To everything here. Also multiply by delta t. If you multiply this one by delta t will also be what? Be here. Instead of, you can simply put the delta t here, but in this case, since you are multiplying and everything here is multiplying, you can simply put the delta t at this point here. Here becomes delta t, or we can put the delta t at this point here. We can put it at this point and also put it at this point. Not as since it is multiplying, we can simply put the delta t here and put the delta t here for the right hand side. So if we do that, this will give us okay. Let's write the constant first before the pressures. So let's take this constant first, these two constants before the pressure. Are you getting me? It's still the same thing as long as they are multiplying. So we're going to take this one first, take this one before the pressure. Then if we do that, we are going to have this is equal to what? B C AX KX divided by mu L BL delta X. We're going to have this multiplying AC BL dot. Then we said that delta T is multiplying. So we add delta T here, delta T divided by VB phi CL. Then multiplying by this one. So here becomes pi plus 1n minus 2pin plus pi minus 1n. So this one now is just for this. So the next step now is to add plus ACL BL delta BL dot all over VB phi CL. So this will be plus AC BL dot. Now remember that the delta T is multiply this one, it also multiply this one. So here also becomes delta T divided by what? VB phi CN multiplying by what? Our QSC. So I can multiply through by delta T. We are going to have this equation. Since we have this, the next step now is this minus PIN. Remember, we are trying to make PIN plus 1 sort of formula. So this minus PIN now will cross to this other side. So if this minus PIN crosses over to this other side, this equation now will be PIN plus 1. Next step is to make PIN plus 1 square formula. For to make this square formula, minus PIN will have to cross to this other side. So if minus PIN crosses to this other side, our equation now, this equation becomes PIN plus 1 will be equal to, we said that minus PIN is crossing to this other side. So if this one crosses, it returns to plus. We are going to have PIN. Remember, it crosses, so there will be no minus, plus. So we'll put this BC AX KX divided by mu L BL delta X, which is just this, multiplied by AC BL dot delta T divided by VB phi CL, which is just this, into this bracket, into PI plus 1N minus 2PIN plus PI minus 1N. Close this bracket, then plus AC BL dot delta T divided by VB phi CL. Remember that this one is multiplying our QXC. So this becomes dot QSC. So we are going to have this equation. Now, since we have this equation already, this equation becomes the general equation that we are going to use to calculate for the pressure distribution during the first year. So for us to get the pressure during the first year, first of all, we are going to compute for the value of this constant and also compute for the value of this constant. Remember that this constant and these constants are all the same. So since that is the case, we just have to compute for the value of this constant and also compute for the value of what? This constant. So let's compute for the value of this constant. That constant is BC AX multiplied by KX divided by mu L BL times delta X. But now, if you look at this constant, we have what? AX. We have AX. What is AX now? AX is the area of the grid block. What is the area of the grid block? For us to get the area of the grid block, we can simply say that the area AX is simply what? 75 times what? 1000. If that's the, we can simply say AX is equal to 75 times 1000, which is equal to what? 75 times 1000 will give us 75,000. Remember, this is feet, this is feet. Feet times feet will give us feet square. So the area of the block now becomes what? 75,000 feet square. The value of BC is given as 1.127. The AS now we calculated it to be 75,000. So I've computed this. The next step is to compute the second constant. The second constant is AC BL dot times delta T divided by VB phi CL, which is equal to. Now let's substitute this. If you look at this, we have AC. Is AC given? AC is given as this. BL dot is given as 1. Delta T. If you look at that, we have 15 days, 30 days, and what? We have 15 days, 30 days, and 10 days actually. So we also have delta T equal to 10 days. So first of all, we are going to compute for 10 days. Then we'll do the one of 10 days for 365 days, which is 10 days divided by 365 days, which is approximately 37 times. We'll do for time level 37. Also repeat the same process for 15 days. Do for about approximately 27 times for 1 year. Then go to time level 30. Do for approximately 17 to 18 times for that particular 1 year. But in this one, we're going to do for 10 days. Then we're going to stop at time level 2. Then you can just go and practice till you reach 36. So let's compute the constant for this. First of all, we're going to make use of 10 days. If you do that, what is our AC? AC is 5.615 multiplied by, what is our BL dot? BL dot is 1. Then what is our delta T? Our delta T is, since we are starting from 10 days, let's use 10 days. Then after 10 days, they will come to 15 days, then 30 days. Delta T will be making use of 10 days divided by, what is our VB? Now, VB is not given. VB is the volume of this block. How do you get the volume of this block? It's very easy. Since this is, to get your VB becomes 1000 times 75 times 1000. If that is the case, our VB will be what? Will be 75 times 10 raised to the power of what? 6. Which is 75 times 1000 times 1000 is our volume of block. So it becomes 75 times 10 raised to the power 6. Then what is our phi? Phi is given to us as 0.18. Then multiplied by CL. What is CL? 3.5 times 10 raised to the power minus 6. So if you compute this, we are going to have 883. 1.1883. So if you compute this, we are going to have this particular value. Since we have this, the next step now is to substitute in place of this particular constant. Just come here and substitute our answer, which is this. In place of this constant, just come here and substitute the answer, which is this. Which is this. In place of this one too, which is the same thing as this. Come and substitute what? This answer. Since we have already calculated for the value of this constant as this, the value of this as this, and the value of this, which is the same thing as this, you can simply substitute them in the equation. So in place of this constant now, simply put this value. So if you put 0.1268 in place of this, you are going to have PIN plus, since we say this one is equal to this, you put that value. And we also say that this one here is equal to this. So in place of this constant, we put this value, then these are the pressures, which is this, plus place of this constant we set is this, which is the same thing as this. Substitute this value into here, then QSC QSC. Now is to calculate for the pressure for each grid block. So calculate for the pressure here, the pressure here, the pressure here, the pressure here, the pressure here. So I'm going to start with when I is equal to 1. I'm going to start with when I is equal to 1. If I is equal to 1, I equal to 1 is at block 1, right? Is at block 1. So this becomes grid block 1. Remember that I said that we are going to perform, since we are using the delta t equal to 10 days, we are going to perform this simulation for about 36 days approximately. So this is the first time of doing it for for delta t equal to 10 days. So this becomes, since it's the first time, it becomes time step 1. So this, since it's the first time, we call type step 1. And also for the first time, the P1n is equal to the P2n is equal to the P3n is also equal to P4n is also equal to P5n, which is equal to 6,000 psi. For the first time, the pressure P1n, P2n, P3n, P4n, P5n is equal to the initial reservoir pressure. In this question, the initial reservoir pressure is what? 6,000. So for the first time, for the time step 1, the P1, P2, P3, P4, P5 are all equal to initial reservoir pressure, which is what? 6,000. That is one thing to take note of. So if that is the case, if I is equal to 1, what becomes our equation? What becomes our equation? Before we substitute I equal to 1, if you look at what we have here, we have Pi plus 1 and what? Pi minus 1. If any of these two pressures is 0, if this one is 0 and this one remains, or if this one is 0 and this one remains, these two here automatically changes to what? To 1. Instead of 2, are going to have 1. Then if this one is not 0 and this one is not also 0, this becomes what? 2. Just like now that we have Pi plus 1 and Pi minus 1. Since the two are here, we have 2. But if any of them is 0, these two changes to 1. Take note of that. Substitute I equal to 1 in this equation. If you substitute I equal to 1, here becomes I is 1. So this becomes P1n plus 1. I'm going to have P1 n plus 1 equal to, this is Pi, I is 1, so this becomes P1. I'm going to have P1n plus, remember that is a constant, 0.1268 into 1.1883, close the bracket. Now here is Pi plus 1. 1 plus 1 will give us 2. So this becomes P2n minus 2P1 raised to the power of n plus 1 minus 1, 0, P0n. Now, then plus 1.1883 QSC. We have this equation. Since we have this equation now, let's if you look at this particular grid block, this is P0, and there is no, our value of I started from 1, 2, 3, 4, 5. There's no P0 here. Since there's no P0, it means that P subscript 0 becomes what? 0. So if P subscript 0 becomes 0, remember that we said that if this one and this one remains, we are going to have 2 here. But if either one of them remains, these two change to what? To 1. So therefore, since P0 is out, we are left with just what? P2. So we only have one pressure. So therefore, these two here will change to what? To 1. These two here will change to 1. Then also, if you look at this now, we have QSC in this our equation. But before you use QSC, you are going to consider the location of the well in your grid block. If you look at this, location of the well is in grid 4. So you only make use of QSC at the block where the location, where the well is what? located. So since the well is not located at grid block 1, right? Since the well is not located at grid block 1, we are not going to make use of the value of what? QSC. We only make use of value of QSC when we get to block 4 because the well is located at what? Block 4. So therefore, our QSC also becomes 0. So here we are going to have 0. If QSC is 0, everything here becomes 0. So we are going to have something like this. Of P1N and P2N, we are going to have P1N, we said that is equal to this, which is 6,000. So we are going to have our P1N plus 1 will be equal to P1N is 6,000. So this becomes 6,000 plus open bracket 0.1268 into 1.883 close the bracket 1.1883 close the bracket into P2 is the same thing as 6,000 for the time step 1. So this becomes 6,000 minus 6,000. If that is the case, 6,000 minus 6,000 will give us 0. 0 times everything here becomes 0. If everything here is 0, our P1N plus 1 is equal to 6,000 PSIE. So we are done with P1N plus 1. The next step now is to calculate for I equal to 2 for grid block what? 2. The same thing we are see at the time step 1. So we'll calculate for that. Calculate for I equal to 2. If I is 2, 2 is located at grid block 2, so it becomes grid block 2. Then we are see at time step 1. So if that is the case, if you put 2 into this our equation, we are going to have P2N plus 1. So this becomes P2N plus 1 is equal to PIN. So our I is 2 becomes P2N plus 0.1268 into 1.1883 into Pi plus 1. Here is I is 2, so it becomes P3N minus 2Pi. I is 2, so this becomes P2N, then plus PIN. I is 1, so I is 2, so it becomes 2 minus 1, which is 1 raised to power what? N plus 0 plus 1.1883 multiplied by QC. Now, if you look at this, QC, we say we always use QSC where the well is located at that block. The well is located at block 4 and not block 2. So therefore, QSC is what? 0. Since it is 0, QSC is at from here. So next step now, substitute the values. So if we substitute values, we are going to have P2N plus 1 is equal to, we said for time step 1, for all of them is what? Constant, is equal to the initial reservoir pressure. So this becomes P2 is 6,000 plus open bracket 0.1268 into 1.1883 into P2, P3 6,000, P3 is equal to 6,000 minus 2 into P2. P2 also is still 6,000, so this becomes 6,000 plus P1. What is P1? P1 is also 6,000. Minus 2 times 6,000 will give us minus 12,000. 6,000 plus 6,000 will give us 12,000. 12,000 minus 12,000, 0. 0 times everything here, 0. So everything here is 0. If this is 0, our P2 N plus 1 is also equal to 6,000 PSIA. The next step is to calculate for when I is equal to 3. If I is equal to 3 is block 3, then that is group block 3. Then we are still at time step what? 1. It's still, we are still at the first time. We will be at time step 1 until we finish 1, 2, 3, 4, 5. So since we are still at 3, we are still at time step 1. So if I is equal to 3, we are going to have what? P3n plus 1 will be equal to P2 PIN, which is P3n plus 0.1268 into 1.1883, open bracket, I plus 1, 3 plus 1, 4. So here becomes P4n minus 2P3n plus P2n plus 1.1883 QSC. So if you look at this, there's no QSC yet, there's nowhere at grid block 3. So therefore, QSC is also 0. If QSC is also 0, substitute values of P3, P4, and P2, we are going to have our P3n plus 1 will be equal to P3 initial was, it will still give us 6,000 plus 0.1268 into 1.1883 into, what is P4? P4 is 6,000 minus 2 into 6,000. That's P3. P3 is also 6,000 here, plus P2, which is also 6,000. Close the bracket. So say that 6,000 here will give us 12,000. Minus 2 times 6,000, still 12,000. 12,000 minus 12,000, 0. 0 times everything here will give us 0. So everything here becomes 0. If this is 0, our P3n plus 1 will be equal to what? 6,000 PSIE. So we are done with P3. The next step now is to move to I equal to 4. I equal to 4 is at grid block what? 4. I equal to 4 is grid block 4. I will remember I was here at time step 1. So if that is the case, let's write the equation for P4n. So I equal to 4, this becomes P4n plus 1. So here now we are going to have P4n plus 1 is equal to P4n plus 0.1268 into 1.1883, close the bracket, into I plus 1. Pi plus 1 here becomes P5n minus 2P4n plus P3n plus 1.1883 QSC. So we are going to have this. So let's substitute values. If you look at this now, our QSC is here because the way is located at block 4. Since the way is at block 4, our QSC will not be 0. QSC will be equal to minus 150. So if that's the case, let's substitute value. If we substitute, our P4n plus 1 will be equal to P4n. P4n is equal to 6,000. So we're going to have 6,000 plus 0.1268 into 1.1883 into Pi plus 1n, which is P5, is 6,000 minus 2 into 6,000. That is our P4n is 6,000. Then plus P3n is also 6,000. 6,000. Then plus we have this, that is 1.1883. Then QSC, what is our QSC? Our QSC is minus 150. So this becomes minus 150. If you compute this, we are going to have P4n plus 1 will be equal to, so if you punch this to your calculator, you are going to have 5821.75. So this is what you are going to have. Then the next step now is to calculate for I equal to 5. Since we have 5 grid blocks, we are going to have I equal to 5 here. Then I equal to 5 is our grid block 5. So grid block 5 times step 1. Also, we write the equation for grid block 5. Remember that at grid block 5 now there is no well. So we write the equation. If I is equal to 5, from here now substitute I as 5. We are going to have what? P5 n plus 1 will be equal to P5n plus 0.1268 into 1.1883 into Pi plus 1 here becomes P6n minus 2P5 plus P4n, then plus 1.1883 QSC. Now, if you look at grid 5, there's nowhere. So since there's nowhere, QSC becomes 0. If QSC is 0, remember, if you look at this, we have P6, but in our grid block, there's no P6. Since there's no P6, P6n becomes what? 0. If what we said that if one of these two becomes 0, that means these two here will change to 1. So therefore, our 2 here will change to 1. So here becomes 1. So substitute values in this equation now. To substitute value, we are going to have P5n plus 1 will be equal to P5 is 6,000 from here, then plus 0.1268 into 1.1883 into minus 1 times P5 is the same thing as P5, which is minus 5,000 plus 5,000. If you compute this, minus 5,000 plus 5,000 is 0. 0 times this, everything here becomes 0. So this will give us P5n plus 1 will be equal to 6,000 PSIA. Since we already calculated for P5 as this now, and there is no other grid block from this, so therefore this becomes the end of time step 1. The next step now is to compute for time step 2. Computing for your time step 2, remember that time step 1, we said that all the pressure is equal to the initial reservoir pressure, which is this. But in computing for your time step 2 now, all the pressure changes. Remember that when we computed for our time step 1, we said that our P1n plus 1 is equal to 6,000. Our P2n plus 1 is equal to 6,000. Our P3 PSIA, this is PSIA. Then our P3 n plus 1 is also equal to 6,000 PSIA. Our P4 n plus 1 is also equal to 5 what? What is the value here? 5 what? 5 5821.75 PSIA. And also our P5n plus 1 is equal to 6,000 PSIA. Now, while you are calculating for your time step 2, instead of your P1 equal to the initial reservoir pressure, your P1n will change. Now, your P1n now will become your P1n plus 1. Then your P2n will also become this. Your P2n will become this value. Your P3n will become this value. Your P4n now will become this value. And your P5n will become this value for your time step 2. So your time step 2, you are no longer using the initial what? Pressure, but you use the pressure that you what? You calculated. So therefore, our P1n plus 1, our P1n for time step 2, our P1n now will become 6,000 PSIA. Our P2n, we said P2n will become this value, which is equal to 6,000 PSIA. Our P3n will become this value, which is 6,000 psia. Our P4N for time step 2 will become this value calculated here, which is 5821.75 psia, and our P5N plus 1, our P5N will be